Alright, hey guys, welcome to the stream. Today I'll be doing, as you already probably know, I'll be doing a computer science overview of the entire curriculum from start to finish. First off, I just want to say Ramadan Mubarak to all my brothers and sisters out there fasting, and to everyone else, good luck in your exams. Alright, let's get started. So, first of all, I want to say that we're going over three exam boards: OCR, AQA, and Edexcel. So there's going to be a lot of variation between them, and I'll specify what's OCR, what's AQA, and what's Edexcel. But I'm just going to go over everything. So first thing I want to go over is the TCP IP model. And this is a very controversial model within the computer science community because a lot of teachers like to teach it in a lot of different ways. So I'm gonna just get straight into it. I like to. This is the right way I would do it. It's application, transport, then internet, and then data. And I like to remember this as Arsenal till I die. That's the way I remember it, and that's the way you're probably going to remember it too. Hated Arsenal till I die. What you want to do is now I'll explain exactly what all of these mean. The application layer of the TCP/IP model is where data is turned data from applications is turned into websites. So it's basically just when you imagine visiting a website, say Instagram, that Instagram page is your application, right? So transport is basically just controlling data flow. So it's taking your information, say your passwords, your email. When you log in, it's taking that information and it's taking it to the website. It's literally that. And the protocols I forgot to say. The protocols is TCP and UDP for transport, and HTTPS and HTTP for application. And then there's internet, which makes connections between networks, and it tells packets where to go. Controls data flow, sorry. Makes connections. Now, data is literally your router at home, or it's the company's router, or the website that you're trying to visit. It's their router or it's your router. It's what it's Ethernet basically. If any of you know what Ethernet is, Ethernet is the cable that connects. It's the physical part of all of this. And the best way to explain that is it's responsible for electrical signals over a network. I'm sorry if that you can't read that, but you can hear what I say, and you should probably understand that. Next thing I want to go over is all the data types. Oh, and the purpose of this live stream is for you to ask questions while I'm going over topics so I can answer them instantly. Yeah, the next thing I want to go over is data sizes, I'm going to say. So there is a bit which is representative of 1. Then there is a nibble, which is 4 bits. Oh god. 4 bits. Then there is a byte, which is 8 bits. Then there is a kilobyte, which is 1024 bits, or it's 1000, oh god, 1024 bits, or it's 1000 bits. Either one will get the answer in the exam, but 1000 bits is more accurate. Then there is a megabyte, which is 1000 and 1024 bits, or no, sorry, 1024 kilobytes. Or it's just 1000, as I said before. Oh god, this is so messy. Then there is, I'm going to rub all this out because it's in my way. And then there is a gigabyte, which is 1000 or 1024 megabytes. Then there is a terabyte, and you can see the pattern here, but it's basically just timesing by 1000 or 1024 if you want to be like that. Yeah, you're just timesing by 1000 every time, but that is the basic thing. And there's also OCR only, petabyte. You don't need to know this if you're Edexcel or AQA, but it's helpful to know sometimes. Yeah, petabyte is 1000 terabytes. Yeah, so that's that, or 1024. Yeah, so those are the data sizes. It's normally we measure everything in gigabytes anyway, but that's what you want to know. Yeah, so I'm gonna go over all of the data storages now. So as of now, there are 3 main ways to store data. And that is optical, magnetic, and solid state. Now, optical is your basic CDs and DVDs. These are very cheap ways of storage, but they go up to around 5 gigabytes if you have a Blu-ray DVD. Magnetic storage is cheap as well, but it goes up. You can get a much larger drive in magnetic storage than you can for solid state, except it's pretty slow. This is very slow. Optical storage is a very slow method of data storage. Magnetic storage is slow, but it's also cheap, and you can get very big magnetic storage devices. Now, solid state, it's fairly new technology. It's from, I want to say 5 years ago, when they came out with the first solid state drive. And solid state is, yeah, that's very interesting live chat right now. I might turn on spam later. Spam protection later. Solid state. It's expensive, but it's also very fast. It's my favorite kind of data storage. If any of you are interested in that, it's expensive. It's fast. It is. You can get it bigger. It is bigger than optical storage. But it's not as, you can't get solid state drives as big as magnetic storage. So I'm gonna say mid to large right now, but that's that. I'm gonna move on to network threats now. So there are lots of different threats that are posed to a network. For example, you can have malware and inside malware there are 4 main types of malware. There is Trojans, there are viruses, bear with me. There are worms, and there is spyware. 4 main types, just keep that in mind. Trojans are legitimate software that looks to be real software, but it's actually something that is stealing your login details, stealing your accounts, stealing your passwords. It's going to be doing something like that, but it looks like legitimate software. It's going to look like, say you downloaded a browser, a new browser, but it's going to look like something like it's going to look like something you need, but it's not. Right, so legitimate software that's actually malware. Viruses is malware that copies itself into files on your system. Worms are malware that copy itself, but they don't copy itself on your system, they send it out to all of your contacts on your computer. So it spreads itself through contacts. Someone asked, you forgot a rat. I'm getting to it. Don't worry. I'm getting to it. Through contacts. Spyware is stuff like keyloggers. A keylogger, by the way, is something that logs your keystrokes. So whatever you type on your keyboard, it will write that up and it will send that to the person who is hacking you. But yeah, keyloggers and stuff like that is very common within the hacking world. Keyloggers, they can record your screen. Spyware can record. They can record your face cam. They can do a lot of stuff with spyware. But yeah, that's malware. And another threat is phishing. These are threats to a computer network, by the way. Phishing is basically just sending out emails. It's receiving emails that look to be from legitimate sources, but actually are not. So yeah, that is emails that look fishy. The next one I want to go over is farming, which is when you redirect. I'm going to write this out. When you redirect a person's web page to another web page, so you can think you might be logging into Instagram one day, but actually you're logging into a hacker's site that looks like Instagram. So it's when you redirect it to a fake page. So that is farming. The next one I'm going to go over is brute force attacks. And brute force attacks are fairly common, as I said before, in the hacking world, as they're one of the easiest methods of getting into an account. So brute force is when you create a program that basically goes through all the possible combinations a password could be on a system. So if you were to you could make a program to say brute force into someone's PayPal account. I'm not saying do this. But this is an example, a hypothetical situation right here. You could brute force into someone's PayPal account if you had their email. You just put their email in. You'd write a program that would go through every combination. So like A, ABC, ABCD, EFG, like stuff like that. That's just an example, but yeah, that's brute force. So all combinations a password could be. Okay, so alright, the next threat is social engineering. Now, social engineering is an interesting one. It's one of my favorites, if you do ask me. Social engineering is something that is hard to define, but basically it's just creating, like, you call up a company pretending to be someone else. You're just manipulating an employee of a company in order to get information. You're manipulating a company in order to gain info. Now, the next one I want to go over is denial of service attacks, or DDoS attacks, or DOS attacks. If you've heard of it before, so DOS. This is very common in the computing world. You have to have heard it before. It stands denial of service. Stands for denial of service. So what a DOS attack does is it takes up a server's resources. How long have I been streaming now? 26 minutes. Yowza. Takes up a server's resources in order to taking up a server's resources will not allow any other person to get into the site because you've taken up all the resources, right? So that's DDoS. Data interception and theft. Well, this is an interesting one, and one that is very clever, and if you did it, no one would be able to tell if it was you. So data interception is, say you're a hacker, and if you wanted to data intercept other people, you'd go to say a coffee shop, Starbucks, Costa, and you would open up a program that would allow you to view the packets of other people, right? So in doing so, you can view emails of other people, you can view the passwords of other people, you can view the usernames of other people, you can steal their cookies, and you can log in to wherever they're in right now. So it's basically, oh no, gotta charge my iPad. Yeah, so it's stealing data. Whoops. Stealing data by physically being near a target. Now, the last threat I want to go over is SQL injection. Now, SQL injection is again a very interesting one. I will say it again. SQL injection is when you. Now, the main way takes some explaining, but mainly I'm gonna use Netflix as an example. So you're logging into Netflix, right? And from Netflix's side, you want to use your email and your password to log in. So from Netflix's side, this is what their program is going to look like. It's gonna say use email dot 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 dot, and there's your email, and password dot 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 to log in. That's a very simplified version of what their program to log you in is going to look like, right? Now, regularly, it would, if you put your email in and your password in, so use email, I'm going to say hab at gmail.com. It's going to look like that, and pass is hab123. That's not my actual password, but this is for example purposes to log in. So that's what it's going to look like regularly, but in SQL or SQL, as people like to say it, it's going to look like this. It's going to look like use hab@gmail.com and pass get me, let's close that, get me the pass to every account on Netflix. And ignore the rest of this code. Now this bit here is what you would type in to the password, but in code obviously, in SQL injection. You would type that as a command in SQL. SQL is a language, by the way. I probably should start with that. SQL is a language that that allows people to set up databases, but that is SQL, and I know a lot of you are probably confused about that, but I'm gonna skip that one for now, and at the end I will explain that to people who have questions. Right, now another threat is poor network policies. Now, poor network policies are is a very big threat, because if you don't have a good network policy, then you're just not a good network. People are going to get into your account, right? Employees can enter a network if you don't have a good network policy. So if you're a manager of a company and you haven't set up access rights for employees in a company, people are going to get into it, and that is not a good thing. So outlines who has access to a network. But yeah, that's it. Say Apple gives access to their entire network to its employees. People who don't need access, like caretakers or janitors, are gonna have access to millions of accounts, millions of iCloud accounts, and that's not a good network policy. A good network policy is going to be giving access to their networks to only high-level people only, like managers, or I don't know, the board, or maybe no one at all. Maybe no one has access, except from the owner, obviously. That's a given. The next one I want to go over. Now, those are all threats, right? I want to go over taking these threats and mitigating them, or preventing them, or identifying these problems and removing them, because that we're going to look at preventing vulnerabilities. Right, so preventing vulnerabilities. The first one I want to go over is pen testing, or penetration testing. Penetration testing is a is how a company is going to know what's wrong with their network. So so a company is going to hire a penetration tester to look at their network, look what's wrong with it, and they're gonna the penetration tester is gonna tell them what's wrong with it, obviously. Um, so there's white box penetration testing, white box pattern testing, and there's black box. I should probably write box pen testing. Right. So white box penetration testing is simulating an insider from the company who had access and is going to do something malicious with the company. Simulating an insider trying to gain information. Now and a black box penetration tester simulates an outsider of the company who is trying to get in, who has no knowledge of what's going on, of the networks that are in the company, and that's what that is. Now, another way of preventing vulnerabilities is network policies, as I said before, but I'm not going to write that down because I've just talked about that. There's also anti-malware, which is stuff like your basic antivirus. Software updates, stuff like that. Actually, software comes as its own category. I spell software wrong. I'm a retard. Stuff a lot. Software. Software. So stuff like updates that patch bugs. It's very interesting live chat, guys. Well done. It's that. Oh, great. Okay, updates that patch. There's also firewalls, which prevent unauthorized access to a network through blacklisting or whitelisting. Prevents literally just a block on your network. That's it. I'm gonna draw a line there. Prevents unauthorized access. There's also user access levels. So obviously, I've said this before. A janitor isn't going to have access to the entirety of a network. Like they don't need that kind of access. So setting user access levels is very important for companies. There is also encryption. I probably shouldn't have written the title. Encryption is important. You can have Caesar cipher or whatever, your favorite kind of encryption. That's very important. There's also passwords. I should have said that. Encryption is just, passwords. That is basically, that's a very obvious thing, but it's worth writing down in an exam, right? Then, next thing I want to go over is searching and sorting algorithms. So binary search. let's go over this one. Right. So we have a list of 3, 4, 7, 1, 2, 11. Now we take the middle number, and if we don't take the middle number, we just take the one to the right, and we'll take this number and say we're looking for the number 7. No, wait, I just realized this isn't going to work. I've made a big mistake. I'm very sorry, guys. I'm very sorry. This is all wrong. What I should have done is 1, 2, 3, 4, 5, 6. We're looking for the number 3. We're looking for the number 2. So we're gonna take the middle number, and if we're not going to take the middle number, we're going to take the one in front of the middle, which is this 4, and 4 is bigger than 2. So we're going to discard this entire bit. We're just going to scribble it out. We don't need it anymore. And then we're going to take this bit here. We've got 1, 2, 3, and we'll take the middle number here, and 2 is smaller than, oh my god, mind my handwriting, guys, I'm sorry. 2 is smaller than 3, right? So we're going to discard this side of the table now. Now we've only got 3, and I've just realised that we weren't even finding. I'm an idiot. Still, 1, 2, 1, 2, 3. I'm sorry, guys. I'm tired, and I'm fasting. That's why. Allow me. Right. So 1, 2, 3, and we're going to take the middle number. And oh my god, guys, it's 2. So we found a number. That is binary search in a nutshell. I really don't know if that helped any of you, but hopefully it did, right? I mean, that's why I'm doing this. Linear search. Linear search. Right. Linear search is just going through every number until it finds it. I don't know why I had to write that down. It literally just checks this one. Oh no, it's not this one. Checks this one. Oh no, it's not this one. Checks this one. Oh no, it's not that one. Checks this one. Oh no, it's not that one. And then it checks this one. And oh my god, it's not that one either. And then it checks this one and it's this one. Right? So that was, in that case, we were looking for 6, if you didn't know. But yeah, we're looking for 6 there. And that is linear search. Now we'll go over the sorts. Right? Now there is, just to recap, that was binary search and linear search. Yeah, so these are the sorts. So we're going to go over bubble sort, and then after this we'll go over merge sort. Bubble sort. It's an interesting one. One of my favourite sorts, if you ask me. Generally speaking, this is really complicated. It gets complicated if you don't think about it properly, but I'm going to go over something that we call the first pass. So this is the first pass of this thing right here. So if an exam question tells you to go over the first pass of a bubble sort, this is what you're going to want to do. So you want to go here. You want to take the first 2, and you want to see which one is bigger. You want to compare them, and it's going to be 3, 9. And then you want to take the next 2, which is going to be 9 and 1, and you're going to compare them, and you're going to find out that 1 is smaller than 9, and then it's going to be like 7, 8, 3. And then we're going to compare 9 and 4, and that's going to be 4 and 9, and that's a 7, 8, 3, 1. Then we're going to compare 9 and 7. 7 is smaller than 9. That's going to be an 8. And I can't go down any further. Bear with. There we go. Magic. Yeah, that's a 9. That's a 4. That's a 1. That's a 3. And then we're going to compare. We're going to compare 9 and 8. And that is just 8 and 9, and 7 and 4 and 1 and 3. And as you can see, it's not sorted yet, and that's because, again, it's the first pass. So if an exam question tells you that it tells you to explain bubble sort, you want to explain bubble sort use bubble sort to sort a list. You're going to want to go through, you're just going to want to skip all of this bit, and you want to just go from here to here, and then you want to do this again. You want to do all of this again, and you want to keep doing it until you get a sorted list. Right, that was bubble sort. Let me rub all of this out. Next thing we want to go over is merge sort. So this is merge sort. Sorting algorithms. Right. Merge sort is literally the easiest sort anyone could ever do. Ever. Like, it's the easiest thing you could ever do. Like, so 3, 4, 7, 8, 1, 9. So all we need to do is split it off into pairs. 3, 4, 7, 8, 1, 9. Right. Now we split it off into an entire list now. So it's just 3, and then 4, and then 7, and 8, and then 1, and then 9. And then we put it back into pairs or fours, if you're feeling fancy. Put it back into pairs, but order them this time, and they're already ordered. 3, 4, 7, 8, 1, 9, and then we literally put it in order again, but that's not what the computer is doing, but yeah, we'll take this one here, we'll take the 1 here, and then we'll take the 3, and then we'll take the 4, and then we'll take the 7, and we'll take the 8, and then we'll take the 9. That's literally it. It literally splits off, and then it comes together again. I want to go over insertion sort now, and insertion sort is an AQA, an OCR only topic, but I want to go over it real quick because it's really easy as well. Insertion sort. So 3, 4, 7, 8, 1, 9. Literally, it goes through the first number, then the second number, then the third number, sees if it's in place, and then it puts in order, right? So it's going to take over here. It's going to take this. It's going to see that that's in order, and then it's going to come to this 1, and it's going to realize that's not in order, so it's going to take it over here. So it's going to be 1, 3, 4, 7, 8, 9 now, and that is the order. I should have done a more complicated list there, but that's insertion sort. Right. Yeah. That's a really weird live chat. guys. Well done. Yeah. I'm gonna go over abstraction now, or just computational thinking is the topic. Computational thinking, and inside computational thinking is abstraction, decomposition, and algorithmic thinking. A lot of people forget about algorithmic thinking. It's the forgotten child of computational thinking. Yeah, algorithmic thinking. Abstraction is removing all the unnecessary detail from a problem. So, yeah, that's abstraction. You've probably all gone over this. I'm not going to go into this in detail right now. Decomposition is breaking down a problem. Breaking down problem. I can't spell. Work for real. Breaking down a problem into smaller ones. Yeah, and algorithmic thinking is just literally, I read this, I took this right out of the exam guide from all of the specs. It's literally thinking logically. That is algorithmic thinking. I don't think you're ever going to get a question on that. But it is in the revision guide and it is in the spec. So if you want to learn that, you can learn that. But I doubt it will ever come in an exam. But if it does, you know it now. So yeah, I'm going to go over von Neumann architecture right now. So that's what I'm going to do. So let's go through it. Von Neumann architecture. This is P1 for. Someone said this is paper 1 for AQA. I'm not going for it in papers because all OCR, AQA, and EdExcel, they have different subtopics for different things in different papers. So I'm just going to go over the topics and hopefully it'll help or something. Yeah, I'm really tired. Yeah, so in a CPU, von Neumann architecture is what's in a CPU. It's the structure of a CPU. Yeah, so inside a CPU, lots of different things. There is the CU, which just controls everything. It just controls the main activity of the CPU. There is the ALU, which is, this is control unit, by the way. This is our arithmetic logic unit. This handles maths, I guess. Yeah, it does all the arithmetic in the thing. I never went over adware. Adware comes under. You're right. I never went over adware. I'm fasting. Like, allow me for now. You know. Yeah, adware I'll go over quick. Adware is just unwanted advertisements. I thought that was pretty self-explanatory, right? Yeah, that's adware. ALU is ALU handles arithmetic, and then there is the clock. These are the three main parts of the CPU, by the way. But the clock handles how fast the CPU runs. So you probably heard of increasing your clock speed. Increasing your clock speed can increase the speed of your computer, because if the CPU is running faster, then the CU is going to be running faster, and if the CU is running faster, then the ALU is going to be running faster. So increasing clock speed makes everything just run faster, because it tells the CPU to just go faster, if you know what I mean. I'll quickly go over the fetch, decode, execute cycle, which closely ties to the clock speed. So fetch, decode, execute. This cycle right here is how the CPU runs. So firstly, the CPU fetches data from the memory, the RAM. It fetches that data, and then it takes it to be decoded in the ALU or the CU. It gets decoded there, and then it gets executed wherever it needs to be executed. So say it's running a program, say it's calculating a calculation or something like that. Cache, right, I'm getting to it. Von Neumann architecture. There is some more. There are the three main components, which is CU, LU, and the clock. There are a few subcomponents like registers, address bus. Just buses in general, but address bus, data bus, and the control bus, and the cache. But technically, cache is outside the CPU. It's not inside the CPU. Registers are the one that are actually inside the CPU, and registers are the fastest memory you can get, because it's inside the CPU, and the CPU can get to it easily. Yeah, so address bus is used when instructions need to be sent. Control bus is used. No, address bus tells the control unit where instructions are. Data bus is the bus that data gets sent along, and control bus is where instructions get sent along. Registers, fastest method of data. Yeah, I should probably go over all the data stuff. Right, that's all that. Yeah, so registers are the fastest in terms of data. And then comes cache, right? This is inside the computer. Then comes cache, and then comes your RAM, and then it's your secondary storage. So your hard drive. Drive, no, that's wrong. Storage. Yeah, so your hard drive or your solid state drive or your, yeah, it's one of those. Right. I think I've gone over a lot. What have I missed? Bear with me. Right, topologies. That's what we can go over next. It's been a long day. It's been a long day. Right, topologies. Topologies are a very important subtopic in computer science. There are 4 kinds of topologies in OCR. There are 4 in AQA. There's 2 in Edexcel. There are 3. So these 2 are star and bus. And the third one in Edexcel is ring. And the last one is mesh. Yeah. So, star. Let's go over star. Star topology is literally arranged in a star, and that shouldn't be very much of a surprise. But yeah, there is this unit in the middle that controls where all the packets go and things like that. This thing here controls the packets that get sent to each and every one of the computers here, right? And a star topology is expensive, but it's also useful in the way that if one of these shuts down, then the whole network is still up and running, right? And that's what's useful in a star topology. However, in a bus topology, it's very different. It's actually arranged in a bus. What a surprise! Yeah, so it's like this. Boom, boom, boom. Something I just messed that up, right? So this is computer. These are terminators. Do not forget that. Terminators. Great, that messed up. Yeah, so terminators. Literally just the end of cable. I don't know why you really need to say that, but you do need to say that if you ask a question about buses. Right, buses are relatively cheap to set up. You could probably do it yourself, but with a star topology, you need a professional to set it up for you. Sorry about that. I've been fasting all day. Again, I'll tell you that. Right. Those are computers, terminators. They're very cheap. However, if one of these shuts down, none of these have access. This won't have access. This won't have access. This won't have access. It's just not very good for all of these other computers, and yeah, it's not very. If you have, say, 3 computers, then maybe it's worth getting a star topology, or maybe if you're on a budget, then maybe it's maybe it's pretty efficient. But if you're not, and if you're a big company, then you need to get a star topology, and that's topology. So I'm not going to explain ring and mesh, because to be honest, I don't really know about that. So if you're doing OCR, then like good luck, and probably like search it up rather than relying on me for your revision. But yeah, I think I've gone over everything. You guys should probably tell me if I haven't. But yeah, I'm gonna check real quick. Trace tables. Let's go over that. This is going to be fun. So, trace tables. This is pretty. You will always find trace tables in examiners want. Examiners like trace tables, to be honest. Yeah, trace tables. Let me find an example question. Right. So, alright. So I'm gonna do subroutine. I'm not really gonna write all this out. I'm gonna say subroutine. Yeah, I'm gonna have to, right? Subroutine. Something like that. Total equals 0, 4, count 1 to number is if count 1 to num total equals total plus 1. You guys probably aren't going to read this. I'm going to be able to read this, but I will draw a trace table in a second and all will be explained. Return total. So I'm going to rub all this out, and this here is the trace table. So num, count, and total. Right. So this is number, this is count, this is total. We're going to go through all of them. So total right now is equal to 0, as shown. Count is starting at 1, so I'm going to put 1 there. And number is, I'm going to say 5, right? Number is going to start at 5. And I can't draw anything. Yeah. Yeah. So this is 5. And this is just a real mess, isn't it? Yeah. This is a 5. This is a 5. This is a 5. This is a 5. And I'm literally going over this very quickly. This is 1, this is 2, this is 3, this is 4, this is 5, this is a 1, 1, 4, 4, 9, and literally no one is probably listening right now, so I'm going to end the stream. Thank you guys for listening. Thanks for coming, obviously. Ramadan Mubarak again to everyone fasting right now. And everyone else, good luck in your exams. I hope you all get 9s. To the people who just came here for dance, yeah, good luck to you. You should probably be revising. yeah, gonna end the stream now. Let's close this. Yeah, so good luck to all of you, and I hope you have a nice day. Good luck revising. No, go revise. Yeah.